Hello students, welcome to our class and start our learning with Let's Learn. Our today's topics Ohm's law, resistance and resistivity. What is Ohm's law? So students, the great scientist, great physicist George Simon Ohm established this law to measure the resistance of any conductor. So what is the Ohm's law? Let's see. If physical state of any conductor remains constant, physical state means solid, liquid or gases. So physical state of conductor remains constant at that time, the current flowing through the conductor, let's see here, this conductor is AB. So current flowing through the conductor, and current is denoted by R, is directly proportional to the potential difference, that is V, between its two ends. Okay, again, if a physical state of conductor remains constant, then the current flowing through it is directly proportional to the potential difference, that is V, between two ends. Okay, so I is proportional to symbol I, that is for current, and V is for potential difference. So I is directly proportional to V. V is the potential difference. This implies I is equals to kV, where K is a constant. K is a constant of proportionality. So just adjust I into 1 upon K. Here I upon K is equals to 1. So I write I into 1 upon K. I upon K or I into 1 upon K is equals to V. Here 1 upon K is equals to R is a resistance of conductor. Okay. Then so write down the R in place of 1 upon K. So equation is I into R equals to V, or V equals to Ri. So V equals to Ri, or R equals to V upon I. This R equals to V upon I. This is Ohm's law. Got it, student? Then what is the SI unit of resistance? So we have this formula, R equals to resistance. Resistance is denoted by capital R, and R equals to V upon I. So SI unit of resistance is the SI unit of volt, SI unit of the potential difference, and SI unit of current. So the ratio of both. So volt upon ampere. Current, ampere is a SI unit of current, and volt is a SI unit of potential difference. So volt upon ampere is a SI unit of resistance, and that is called the ohm, and the symbol of ohm is this. Okay, so ohm is a SI unit of resistance. Just observe this picture here. This is the potential difference. If current flowing from this conductor, then if resistance is R, then the R is V upon I. This is a formula. I is a current flowing through this conductor, R is a resistance, and V is a potential difference between two ends of the wire, two ends of the conductor. Got it? The next, resistance of 1 ohm. So student, we have this formula, ohm equals to volt upon ampere. Ohm equals to volt upon ampere. So what is a 1 ohm? So just put the value of 1 ohm is equals to, if we put the value of volt equals to 1 volt and 1 ampere. 1 volt and 1 ampere. So 1 upon 1, that is equals to 1. So what will be the definition of 1 ohm? So if 1 ampere current flows through this conducting wire, when 1 volt potential difference, if the potential difference will also 1 volt between between its ends, then the resistance of the conductor is 1 ohm. Okay, so this was the definition of the 1 ohm. Then next, resistance and resistivity. So what is a resistance? So students, you know, if any conductor, the electrons move randomly. Electrons move randomly before joining the cell. These electrons move randomly. Okay, direction of electrons is randomly. But if we join the cell, if we connect the cell, then the electrons move in a specific direction. The electrons move from the lower potential to higher potential. Understand? So when the electron move from a lower potential to higher potential, so moving electron strikes the atoms and the ions. These moving electrons strikes the atoms and ions. Okay, and which lie along their path. Which electrons or which ions lie their path, and such collision of these electrons, such collision causes the hindrance to flow the electron. That is called the, that means they oppose the current. Understand? So this collision oppose the current flowing of the, because when the current flow, electrons flow in this direction, then because of the moving of electrons, current flow through this conducting wire. So because of the collision of the electrons and the ions or atoms, so they oppose the flowing of current. And this is called the resistance. So just see what is the resistance. Resistance is defined as the property of conductor. That means this conducting wire. Property of conductor which oppose the flow of current. Understand? What is the reason of flowing current? When electron moves, then in a specific direction, then current will also move in the opposite direction of the motion of electrons. So the resistance is defined as a property of the conductor which oppose the flow of electric current, and it is also defined as the ratio of voltage applied to the electric current following through it. Okay. So the resistance of conductor depends on the followings. This resistance depends on the following. First thing is the length of conductor. First is a length of conductor. What is the length of conductor? So just this is a conducting wire. So what is the length of conductor? That is denoted by L. And second thing is a area of cross section of the conductor. This area of cross section of this conductor, that is denoted by capital A. So this resistance depends on these two factors: the length of the conducting wire, the length of the conductor, and the area of the cross section. Again one factor, the nature of the materials that is used in the manufacturing of the conductor. So these three factors, so resistance of conductor depends on these three things. Okay. The next R is, so the relation of resistance, the R is directly proportional to this L, directly proportional to this length, and R is inversely proportional to the area of cross section. R is directly proportional to L. This is first. And the second relation, R is inversely proportional to A. A is the area of cross section. Then join this both 1 and 2. So area R is proportional to L upon A, or L into 1 upon A. L into 1 upon A, or L upon A. This is a relation. So R, observe in this picture. So R is proportional to L upon A. Then R is equals to, just remove this proportional symbol and put this rho symbol. So R is equals to rho L upon A. What is rho here? So rho is a constant of proportionality, and it is called the resistivity of material. Understand? So this is called the resistivity. Got it, student? Here resistance directly proportional to the length of the conductor, inversely proportional to the area of cross section, and so R is proportional to L upon A, and R equals to rho into L upon A, where R is a resistivity of material. Okay. Then next is a SI unit. What is the SI unit of resistivity? So SI unit is ohm meter, because rho equals to resistivity. So rho equals to, again we have the formula here. R equals to rho L upon A. Okay. Then we have to find out the SI unit of rho, SI unit of resistivity. So rho equals to RA upon L. Rho equals to RA upon L. Where the unit of resistance is ohm. Then A, the SI unit of A, that is area, is meter into meter or meter square. So meter into meter upon L means length. So length, SI unit of length is meter. So just cancel out meter, and remaining ohm meter. So SI unit of rho is ohm meter, and rho is the resistivity. So the SI unit of resistivity is ohm meter. Understand? So here the is ohm, the symbol of ohm meter. Got it, student? So resistivity is then definition. What is the definition of resistivity? So resistivity is a specific property of material by which this conductor is manufactured. Understand? So resistivity is a specific property of material, and different materials have a different resistivity. Different material having a different resistivity. So let's see what is the resistivity. Resistivity means the specific property of material. Resistivity rho is defined as the resistance offered by the materials per unit area. Understand? Offered by the material per unit length for unit cross section. Means we have the formula of rho equals to RA upon L. That means if the value of L is 1. L means the length. Value of A is 1. And value of R is 1. Then 1 into 1 upon 1, that is 1. So the resistivity is defined as the resistance, or here if you put the value of A into L is 1. So rho equals to R. Okay. When we put the value of A equals to 1 and L equals to 1. So the rho is R. Rho is equals to R. So what is resistivity? Resistivity is defined as R, and R is a resistance. So resistivity is defined as a resistance in which condition? When the length is 1 and area of cross section is 1. Length is 1, area. Just I repeat it. We have this formula. Rho equals to R into A upon L. Okay. If put the value of A equals to 1 and L equals to 1. If we put the value of A equals to 1 and L equals to 1, then rho equals to R. We will have the rho equals to R. In which case when we put the A equals to 1 and L equals to 1. So resistivity is defined as the resistance. Resistivity is equals to the resistance offered by the material per unit length and per unit area. Per unit length and per unit on or for per unit area of cross section. Got it? The next SI unit of resistivity is ohm meter. Already explained. Then resistivity increases linearly with the temperature. That means if temperature increase, the resistivity change. Temperature decrease, resistivity is change. So resistivity is increased linearly with temperature. That means with we increase the temperature, then the resistivity will increase. So the resistivity of conductor is low when as compared to the resistivity of insulator. That means the conductor having the low resistivity. Conductor having a low resistivity because the in a conductor the current flow from the conductor, and insulator resist the flowing of current. The insulator resist the flowing of current. So the resistivity of conductor is low. Resistivity means to resist the flowing of current, to resist the flowing of current. So if this conducting wire is a conductor, then current flow, okay, maximum current flow. But if this is an insulator means they resist the flowing of current, so the current will not flow with this insulator. So resistivity of conductor is low and resistivity of insulator is as compared to the resistivity of insulator. Understand? That means the resistivity of conductor is less than the resistivity of alloy, and that is less than the resistivity of insulator. Got it, student? So I hope you understood this topic. What is the resistance and resistivity? Just remember, resistivity means to resist the flowing of current. Resistance means the obstacle. If the electrons flow, in this conductor, then they collide with the atoms and the ions. So that's why they provide the resistance of conductor. So here the formula of resistivity, that is rho is equals to R, that is resistance A upon L. A is the cross section, area of cross section, and L is the length of conductor. Got it, student? So this was our today's lecture. I hope you understood. If you have any query, you can message me. Thank you very much.